Hello children, today we will be learning a topic in optics. In today's lecture, you will learn about the image formation by different types of mirrors. Before starting the image formation, with the help of the ray diagram, we should discuss about incident rays and reflected rays. There are infinite number of rays emitting from a point source. Object can be a point source, a point object, or an object can be an extended object. If you have a point object means object with very small size, then there is no meaning to understand about the extension. If you are talking about an extended object, different points on the object can be taken as point source, and we can form images for all the points lying on the extended object and then join them. That will be the image of the extended object. So first thing you have to remember that an infinite number of rays are emitted from a point. An infinite number of those rays can be allowed to incident on the mirror. But it will be tough to draw the diagram if you will be drawing a number of rays. So for convenience, we draw only two rays from a point on the object, and we find the image as if the reflected rays intersect at a point, then the point is said to be a real image, and if the reflected rays appear to be coming from a point, then the point is said to be a virtual image. So let us start that what are the rays which can be considered to form the image. So rays to be used in drawing ray diagram. For the image formation. First, you see, if you have a concave mirror and you have a convex mirror, this is the principal axis, this is the principal axis. If a ray is incident parallel to the principal axis, and very very close to the principal axis, they are called paraxial rays. And paraxial rays pass through focus after reflection. In case of concave mirror, suppose this is the concave mirror and this is focus, so this ray will pass through focus after reflection. In case of convex mirror, it appears to be coming from the focus. You see, it appears to be coming from the focus. Second one, if you take a ray through center of curvature, suppose this is pole, and this is center of curvature. This is here center of curvature. Means a ray is allowed to pass through center of curvature. It will reflect back along the same path. In this case also, the ray towards the center of curvature will reflect back along the same path. You can ask, what is the reason that we have this type of situation? The reason is that, you know, when a ray is incident normal to the surface, that is, it is along the normal. What is the angle of incidence? Angle of incidence will be 0 degree. And if angle of incidence is 0 degree, by laws of reflection, angle of reflection should also be 0 degree. So when a ray of light is incident along the normal, it reflects back along the same path. All those rays which will pass through center of curvature will be normal to the surface of the mirror. That's why they will reflect back through the same path. That is, it retraces its path. Third is that if a ray of light is allowed, to pass through focus, suppose this is focus, and a ray of light is allowed to pass through focus, it will reflect parallel to the principal axis. If it is a convex mirror, you see, this is focus, it will reflect parallel to principal axis. So out of these three rays, we can take any of the two rays to draw the ray diagram. We can also take the rays, whatever will be required as per the situation, but there we have to follow laws of reflection, that is, angle of incidence will be equal to angle of reflection. Is it clear? Okay, so these are the rules for the incident rays to form images with the help of different types of mirrors. So let us discuss image formation by concave mirror now. Image formation by concave mirror. Image formation by a concave mirror. You know, there are 3 points with a great importance in case of mirror. One is center of curvature, other is focus, and third one is pole. So we will compare the distance of the object with respect to these 3 points. So case 1 will be for the object at infinity, means when an object is at infinity, when an object is at infinity. Now one thing should be remembered here, that what is the meaning of infinity? What is the meaning of infinity? Infinity doesn't mean that you cannot measure. Infinity is a comparative term here. Suppose you are using a concave mirror of focal length 10 centimeter. 50 meter will be supposed to be infinity. 30 meter will be supposed to be infinity. Okay, means if an object is placed at very, very large distance from the mirror, it is said to be at infinity. Suppose this is a concave mirror, a concave mirror. This is the principal axis. This is pole. This is center of curvature. An object is at infinity. One thing should be remembered here. If a real object is placed at infinity, all the rays coming from the object will be parallel to the principal axis or will be parallel to each other. Means the rays coming from the object at infinity are parallel to each other. So if the object is at infinity, they will be emitting parallel rays. Suppose one of them is this one. Means this is the ray coming from the object at infinity. So it will be reflected like this. There is another ray coming from infinity. These two rays are parallel to each other. It will reflect along this side. So they meet here. It means the image is this one. And this is called focus of the mirror. That is, whenever an object is placed at infinity, when an object is placed at infinity, the image is obtained at focus. You have to know about characteristics of the images. Characteristics of the image. You see, first, nature. So you can see here the image is inverted. Object was in the upward direction and image is in the downward direction. So image is inverted. Image is obtained due to the actual intersection of reflected rays. These are the reflected rays. They are actually intersecting each other at A dash. So image is real. That is, nature is real and inverted. Second, position. See the position of the image. It is at F. So at F. Third, size. You see, size of the object is very, very large. What does it mean? The image is very, very small. Means highly diminished. Highly diminished. You can also call it very, very small in comparison to the object. Highly diminished. Have you understand the characteristics of the image? Image is real and inverted. Image is at F and image is highly diminished. Okay. So this is the ray diagram. Now case 2. Just see the case 2. Case 2. When an object is beyond C. Beyond C. This is a concave mirror. This is the principal axis. This is focus. This is center of curvature. You know, focus lies between center of curvature and pole. Now object is beyond C. This is the object beyond C. AB is the object, it is beyond C. So one ray will be taken as parallel to the principal axis. You see, this is parallel to principal axis. And you know it will pass through focus. it will pass through focus after reflection. Another ray is incident through center of curvature. It will reflect back along the same path. So this will be the position of A dash, and this will be image. Means A dash, B dash is the image. A dash, B dash is the image. You see it. A dash, B dash is the image. Now, the characteristics of the image can be like this. Characteristics of the image. Again, this image is real and inverted because it is obtained by the actual intersection of the reflected rays. It is upside down. So this is real and inverted, real and inverted. Position, you see the image is between F and C or C and F. So image is between C and F, between C and F. And size, you see the size is comparable. It is not very small. So size means diminished. This is diminished. This is not highly diminished. This is diminished. So these are the characteristics of the image. Have you got? Real and inverted, between C and F, and diminished. This is the characteristic of the image. After then, we'll be discussing the case 3, when an object is at C. Case 3, when an object is at C. One thing should be asked from your side, that what is the difference between the object beyond C and between the object at infinity. Beyond C means, suppose the radius of curvature is 20 centimeter. The object is at 25 centimeter. The object is at 30 centimeter. The object is at 35 centimeter. These all are beyond C. And if the object is at 20 meter, means it is infinity. If it is at 30 meter, it will be at infinity. If it is at 50 meter, it will be at infinity. So have you understand the difference between at infinity and beyond C? Although that is also beyond C, but that is far, far away beyond C, and this is nearby C, beyond C. These are the differences. Now in case 3, you have the object at C. You see how will the image be formed. If an object is placed at C, this is the concave mirror. You draw a concave mirror. You draw a principal axis. You take C and you take F. You put an object at C. This AC is an object. You take a ray of light parallel to principal axis. Obviously, you know it will pass through focus. So it will pass through focus. Now you cannot take the ray parallel to, you cannot take the ray through C, because if you will take the ray through C, that will not incident on the mirror. So you take a ray through F. You see this will be parallel to principal axis. And finally the image will be obtained here. The image will be obtained here. This is A dash. Is it clear? You just see the image formation. This is the image at C. It is real because it is obtained due to the actual intersection of these two reflected rays. It is inverted, upside down. You see A is at the top, A is at the bottom. So this is the ray diagram for image formation by a concave mirror. Now write down the characteristics. Again, real and inverted. Position at C. Size same as the object. Same as the object. Same as the object. Means its size is equal to the size of the object. nature real and inverted, position at C, and size same as the object. After then you have to know about case 3, case 4 now. Case 4. You see case 4. When an object is between C and F, between C and F, then what will happen? This is the concave mirror. Concave mirror. This is the principal axis. This is center of curvature. This is focus. A ray is between C and F. It is AB. You can take a ray incident parallel to principal axis. It will pass through focus after reflection. Take another ray through center of curvature. It will reflect back along the same path and they will intersect each other here. This is A dash, B dash, A dash, B dash. So this is the image formation. You can take it D. Now see, again the image is real and inverted. Position is beyond C and it is magnified. This is this one and image is this one. Means image is magnified. So the nature is real and inverted. Position is beyond C and size is magnified. This is magnified. So this is the fourth case. Size is magnified. Are you understanding? Size is magnified. Okay, after then we will be having fifth case. See case 5. When the object is at F. When the object is at F, then what will happen? Object is at F. Means when the object is at F, focus. Now let us draw the diagram. This is the concave mirror. Concave mirror. This is the principal axis. This is the focus. And this is center of curvature. Object is at F. You take a ray parallel to principal axis. It will pass through focus. Take another ray through center of curvature. It will reflect back along the same path. You see these rays are parallel to each other. These rays are parallel to each other. Parallel to each other means they will meet at infinity, because you know two rays parallel to each other are supposed to be coming from infinity, and the two rays parallel to each other are supposed to be intersecting each other at infinity. So the image is real and inverted. Position is at infinity and size is highly magnified. Highly magnified. The image is very, very larger than the object. Image is highly magnified. Got it? Image is highly magnified. Okay. So now let us have case This was case 1 case at infinity, second case beyond C, third case at C, fourth case between C and F, and this was the fifth case when object is at F, case 5. This was case 5. And now we will be having case 6 when the object is between F and P. Object is between F and P. You see what will happen now. Object is between F and P. Let us take the situation. Object is between F and P. This is the mirror and this is the principal axis P. This is center of curvature C. This is focus F and object is between F and P. Object is between F and P. Try to understand. Take a ray of light parallel to principal axis. It will pass through focus after reflection. Take another ray of light through center of curvature. It will be like this. You see, these two rays are diverging rays. Diverging rays means the distance between them increases. So they will never intersect each other at a point. Hence, if you will extend them back, they can meet here and the image will be obtained here. A dash B dash. Here you see the image is obtained due to the virtual intersection of the two reflected rays. Hence it is virtual. Another thing, it is direct. You see A is at the top, its image A dash is at the top. So the image is virtual and direct. Position is beyond mirror and size is magnified. So we can write the characteristic nature virtual and direct. Position behind the mirror. And size magnified. Size magnified. Okay, so you got the image formation by a concave mirror. Now let us review all these. In case 1, you observed that when the object was at infinity, the image was at F. When the object is beyond C, image was between C and F. When object is at C, image is at C. When object is between C and F, image is beyond C. When object is at F, image is at infinity. What does it mean? If the position of the object will be changed to the position of image at that time, then the position of the object will become the position of the image. Means position of image and object can be interchanged till the object lies up to focus. When the object is between P and F, image is virtual and direct. And in all the other cases, the image is real and inverted. Understand? Another thing, what can you conclude? When the object moves towards the mirror, image moves away from the mirror. Means when the object is moving closer towards the mirror, image moves away and away from the mirror. So these were the ray diagram for the image formation by a concave mirror. In the new lecture, we will be learning about the ray diagram for the image formation by convex mirror. Thank you.